Good morning, everyone.
Good morning.
Okay, so do you have any question? No, not anymore.
Well, I have a question. What I gotta do is something.
Huh?
How come you couldn't do it to the people that are just walking in? Why couldn't you tell them that was the final today?
Because they are.
Why do you always have to put it on me?
Because the finals today.
No, because you asked me.
See, look. Now she's getting all serious about it.
You don't know too?
Oh my
wow.
God. What? Today? Yeah.
Yeah, the finals today. I walked in and she was like, the finals today.
No, you didn't walk in. You were sitting there. You asked me, do we have final today? I said yes. And I got you for at least 4 or 5 minutes.
It's on my calendar, so I know you're lying.
See, she has a calendar. You all should have calendar. Don't trust your teacher.
Don't ever trust Mr. Dodge.
Don't ever. Okay, do you have any question?
Wait, when's that?
Huh?
When is it?
When's the final?
Final? Okay, I want to be
It's Monday.
100% honest with all of you.
I don't know if she's honest now. I don't know if you're being honest now.
Exactly. So, okay, check your syllabus. Where is the syllabus? That's it.
Being shit. Bro.
Okay, syllabus says final is on May 6th.
Always makes sense.
May 6th.
Always makes sense.
Chapter 7, 8. Oh, no, sorry, that's a math.
That's
So, statistics. Final is May 6th, chapter 12, 15, 16, 17.
May 6th. May 6th. So it's on May 6th?
No, it's chapter 12, probability. Chapter 15, sampling distribution. Chapter 16, confidence interval. 17, hypotheses that we are going to talk about today. These are not basics. These are.
I mean, like on May 6th?
May 10th.
Oh, I thought you were saying basics. This statistic is not, I mean, these chapters are not basic. Yes,
Oh, yeah.
May 6th.
They're basics.
May 6th. In class.
I don't know if that's really the date, guys. Is it May 6th?
Do you have any questions? Okay, so today I'm going to start chapter 17. I guess today, all today I'm going to write down all the procedure of doing hypothesis test. If we have time, I will show you examples, but these are something that I have to follow before we are ready to solve any question. Okay, so hypothesis test. Previous chapter we were talking about mu, population mean, correct? So we were using confidence interval to give an estimate for mu. Mu is population mean, we call that true mean. Or true mean. So we know that mu is unknown, so that's why we are estimating mu, correct? We use x bar, which is a sample mean, to give an estimate about mu. So in this chapter also, we are going to talk about mu, finding mu, and previous chapter was giving a boundary for mu. This chapter is about a question regarding mu, if we are going to reject those claims or we cannot reject them. Okay, for confidence interval chapter, we had some kind of assumption that we should follow. The first assumption we said, we should have SRS, simple random sample of size n, from a population. Then we said this population that we are talking about should have a normal distribution with a mean mu, a standard deviation sigma. Then we said, in this population, sigma is known, the standard deviation of population is known, but we don't know mu. Mu is unknown. So obviously we don't know mu. That's why we are giving estimate about it. The same assumptions is going to, we are going to follow the same assumption in this chapter also. When we are talking about mu, when we are giving, when we are talking about hypothesis test, we will have the same assumption. So these are the assumptions for chapter 16 and 17 when you want to apply confidence interval, when you want to, work on hypothesis test. So our aim here is to give an estimate about mu. Estimate for mu. There are some steps. Step 1. In step 1, we should have hypothesis. We should write down our hypothesis. So now, what are these hypotheses? We have either a null hypothesis which we show it with H0, we call that H0. H0 is the claim. This is a claim. Comes from the statistical test. And we can say this is an initial claim that is mostly based on previous analysis. Or a study. The null hypothesis also is a claim of no difference. So I will write down, this is the claim of no difference. Also, no change. Also, no effect. Because we are talking about mu, we show a null hypothesis like this. Mu equal to mu naught. So this is a place we are talking about no difference, no change, no effect. Means this mu of population is not different from this number. Now what is this number? Mu naught is the hypothesized value. So for example, I can say my null hypothesis is mean of exam score is not different from, 0 is too low for mean of exam score. So let's say 72. So mean of exam score is not different from 72. Or there is not a change between mean of exam score and 72. So what is this 72? This is a hypothesized value. And the mean you see here is mean of population. So I had a population and I took a sample from that and I hypothesized this population will have an average test score of 72. So that's why I set up the new population mean to this one. So now I have a sample, right? I will have mean from this sample, some other information from this sample. Then I am able to, follow up and write down the rest of, the steps using z-value, using test statistic, and answer my question. Am I right? Mu of population is equal to 72 or not? Shall I reject this? Or I cannot reject this based on the further evidence that we are collecting. Do you understand this? So this is our claim, and we want to prove, we want to bring more evidence to see if our claim is correct or not. So in a statistic, maybe I use term like correct, but I cannot use it because we are not always 100% sure that we are right. So we can say either I'm rejecting this or I cannot reject this based on evidence. So using this term correct is not that correct. We cannot use it. Now in this class I will use that term, but overall, when you want to deal with real data set or you want to write a project or research, you cannot use this term. It's not correct. You should say either reject or we cannot reject based on evidence. Okay, so this is the null hypothesis. For each null hypothesis, we will have an alternative hypothesis. We show that with HA. HA is the alternative hypothesis. So our hypothesis overall includes a null and alternative. These two are mutually exclusive. The alternative hypothesis is a claim. But this claim comes from population, comes from people, comes from scientists. So here I will write down HA and H0 are mutually exclusive. So sometimes actually you will see H1 because that one is 0. Instead of HA, you may see H1. Both of them representing the alternative hypothesis. They are not similar. They are kind of, I cannot say opposite, but kind of, yeah. So HA can have 3 different way of writing and expressing. The first way is like this. Your HA can be mu less than mu naught. Mu naught is exact same as that number we have there. If our alternative, if our null hypothesis has this mu naught, our alternative will have the same mu naught, like 72. So, for example, if I'm following up that null hypothesis, my alternative will be mu average of test score is less than 72. So the null says there is not any difference between 72 and average of test score, but alternative says yes, there is a difference, and we guess average of test score is less than 72. So what happens? If you reject this, means that one is correct. I mean, I use correct, but I'm over and over telling you we cannot use correct. Means we cannot reject this one, right? So if we reject null, means this one is correct, right? If we cannot reject this, means this one is rejecting or it's not correct. Do you understand it? That's why we say mutually exclusive. So kind of, opposite. Whatever decision we make on null hypothesis will have effect on our decision on alternative. Okay, this was one case, right? I can say my alternative can be HA mu greater than mu naught. The average of test score is greater than the specific number we are, claiming. And in that example, my mu naught was 72, so it means the average of test score is greater than 72. The third case says the H naught alternative can be mu not equal to mu naught. So it means I'm not 100% sure if I want numbers lower than this, or if my average is lower than this number or greater than this number, right? So I say, I know the average is not equal to 72, but I'm not sure if it is less than or greater than. So HA, based on that mu naught, will be mu not equal to 72. So, for each null hypothesis, we will have just one alternative hypothesis. Either this is my question, or this is my question, or this one. So, if my question is this, I guess the average of exam score is lower than 72. So now let's set up our null hypothesis and alternative. I said less than 72, right? So I will say, I know null hypothesis is always equality, because this is the claim of no difference. So it's always equal sign. So equal 72. And then my question was this. I want to see, I guess, the average exam score is less than 72, correct? So the mu naught will be less than 72. And this will be my hypothesis test. And this is the base of any hypothesis test. If you don't have this, you cannot answer any question. So you should, first of all, you should have a null and alternative hypothesis. Sometimes it can be 0. I say, okay, I think the temperature today, the average temperature is not equal to 0. Not equal to 0. So my alternative will be mu not equal 0, and null is always equal sign, right? So this is the way we write down our null hypothesis and alternative hypothesis. So this alternative hypothesis you see here, this one, we are talking about just one side of this number, this specific value we have, this hypothesized value. So if you're just talking about one side, either less than or greater than, we call this alternative one-sided alternative. So this one also is one-sided alternative, correct? So this one is also one-sided alternative. But this one, we are talking about both sides, right? Less than or greater than, correct? So we call this two-sided alternative. So the first step was stating our hypothesis. Stating our hypothesis. Do you have any questions so far? Okay. So the second step. So this was stating the hypothesis. The second step is test statistic. Finding the test statistic for our study. Our test statistic is familiar to you, based on Z. Z is equal to X bar minus mu naught divided by sigma over square root of n. So definitely this one is the hypothesized value, for example, in that question 72, in that temperature question 0, right? So you will have it in the question. Then you will definitely have your sample mean. For a sample of size n, you will have an average of sample, right? And then like previous chapter, we said sigma is known. So we will have a standard deviation for our population. And we know that, I told you last time, even though we have sigma standard deviation of population, that one is sometimes, impossible to find. So for that situation, this is just a basic kind of hypothesis and confidence interval using z-value. And we are assuming that we have sigma. But later we will have a t-test that says, okay, we don't have none of them, we don't have any of them, we don't have sigma, we don't have mu. In that situation, we will have a t-test, and that is different. So now, we have a kind of assumption for sigma. We will have a sample of size n. For this sample of size n, we will have a sample mean, and then this is the hypothesized value, mu naught. And you calculate this, you will get a z-value. So we call this a test statistic, z-test statistic. Then this is the step that most of you are familiar because we had this z-value before. Then the third step is using the previous steps to find the p-value. So in this step, we are calculating the p-value. P-value is the probability of observing the result. Probability of observing the result. When we assume the null hypothesis is correct. So p-value give us a probability of observing result based on the kind of assumption of, okay, what happens if null is correct? So what is the probability for that? And then we use this p-value to either reject our hypothesis or not reject our hypothesis. So now, for each of this alternative you see here, we will have a p-value. Let's say my test is like this. I will have a specific p-value for this test, this hypothesis. Let's say my hypothesis alternative is this one. I have a specific p-value for this one. So for each of them, we have a way to calculate the p-value. So again, I will separate this to 3 parts. 1, p-value when HA is mu less than mu naught. Then another one, p-value when HA mu greater than mu naught. 3, p-value when HA says mu not equal to mu naught. So as you see, I'm using the previous step. First, I'm using this one, means what was my alternative? So if your alternative is wrong, you stated wrong, the p-value you are finding will be wrong. So based on your first step, and now the second step. It says if p-value is mu less than mu naught, the sign here is less than sign, right? P-value is equal to the probability of z less than the test statistic. So let me write this down as a smaller z. So you can understand which is which. Test statistic. So you definitely from previous chapters, you know if, for example, you find z equal 1.22. Let's say we calculate the z test statistic and we get 1.22. And then our alternative is like that. So we write down probability of z less than 1.22, which is which side? Left side, less than, right? So, and then you find this from table, correct? So that's why I wrote down less than, but it means on the left side of z value. So this is the p-value when we have this alternative. Because of the sign of alternative, the sign here is less than sign. Okay, so now I think you can guess. The p-value here is probability of z. Can you guess? Greater than, right? Greater than the test statistic. This one is maybe, actually, let me continue that. So when, for example, your z is 1.22 and you have that alternative, second one, you will write down something like this, right? And then what happens? The area now we are interested in is on the right side. And then to get this, you know, you should find this and then subtract this from 1, right? So that's why I will write down and continue this in this way. 1 minus the probability of z less than small z. Do you understand this? Huh? So you just sign, because here I said if you want to find greater than sign, what you do, you find this from table, which is a less than sign, subtract this from 1, right? So that's why 1 minus less than sign, right? The smaller part. For this one, p-value is equal to 2 times the probability of z greater than absolute value of test score you find. This one is absolute value of the test score. Test statistic.
What is the absolute value?
Absolute value. What is absolute value? What absolute value does?
Which is positive.
The distance of a number.
Distance from 0 to that specific number. So either we have negative number or positive number. Absolute value is always a positive of those numbers, right? So if I have absolute value, I find z 0.58, and then let's say I have the last alternative, mu naught equal to mu naught, okay? So 2 times probability of z greater than absolute value of negative 0.58, which becomes positive, right? So you will have 2 times the probability of z greater than 0.58. Because this is a two-sided, we have to get p-value from this side of distribution and that side. That's why we have 2 of them. So now this one can change to the 1 minus probability of z less than 0.58. Am I right? Because this is a greater than sign, right? And if it is a greater than sign, we always change it to the less than sign by subtracting that from 1. Correct? So it will be 2 times the probability of 2 times 1 minus probability of z less than absolute value of z. Because still, this is just a formula, right? I don't know if z is positive or negative, so I'm keeping this. Do you have any questions so far? So this was the way you find the p-value. So either of this will happen, not all of them. Based on your alternative, you will have a p-value formula, correct? So as soon as you find the p-value, you will move to the other step which is step 4. Step 4.
So is that the answer? Probably.
Not yet. We have to move to another step and compare this probability with a significant level alpha. So in step 4, we compare the p-value that we got from the 3rd step we compare this with alpha. We call this alpha. Alpha is the level of significance. This is given to you in an example. alpha level of significance is also a probability. Is a probability of rejecting H0 null, assuming that null is correct. Null is correct. So all of these probabilities, they assume that, okay, what happens if this null is correct? Either we are rejecting this or we cannot reject this. So all of these, the base for all of these probabilities are like, what happens if null is true? What happens if null is correct? Either we are rejecting null or we cannot reject it based on other evidence we get. So always the assumption for them is, let's say null is true if we have enough evidence to reject, or if we don't have enough evidence. Okay. So this alpha actually can be, there are three popular alpha. One is 0.01, and you can say 1% level of significance. 0.01 or 1%. The other alpha maybe you see is 0.05, which is 5% level of significance. And then the other one is, which is, I mean, that's not as popular as 5% and 1%, which is 0.1, 10% level of significance. And if you remember, in previous chapter, we had C, level of confidence, correct? So level of confidence C is equal to 1 minus C, level of confidence is equal to alpha. So if our level of confidence was 90%, the alpha is 10%. If our level of confidence was 95%, alpha is 5%. If our level of confidence was 99%, alpha is 1%. Those are the popular level of confidence you saw, right? So for each of them, we have alpha, level of significance. So that this is not that important to know, just it was for your knowledge. Okay. So this step is the last step. Comparing alpha with p-value. And this is a step that you are making conclusion. So this step, you make a conclusion comparing alpha and p-value. For your conclusion, there are two different cases, either this one or another one. Either you are rejecting the null or you cannot reject the null. So either of these happens based on all the evidence you have, all the probability you have. The first case, 1. If p-value is less than equal to alpha, and the other case is the p-value more than alpha. Here we call this small p-value, and this one is our we have a big p-value or large p-value. diagram. If our p-value is less than alpha, or our p-value is small, I told you the alpha level of significance is given to you, like the way I gave you the C, to construct a confidence interval. So whatever p-value you get from the previous step, you will compare with the alpha that I'm giving you, either 1% or 5% or whatever. Then if p-value is less than that alpha I gave you, you will say, we reject the null hypothesis, means we have enough evidence to reject the null hypothesis. In parentheses, I will write down, we have enough evidence to reject the null hypothesis. So, in this situation, when p-value is small, we are saying we reject the null hypothesis, or we say we don't have enough evidence. We have enough evidence to reject the null hypothesis. So now let's go back to our example. Our example about exam score, I said mu equal to 72, HA mu less than 72, for example. This example I'm talking about. So what happens if I reject the null hypothesis? Yes, exactly. Do you understand this? So if I reject this, means I cannot, I don't have enough evidence to say this one is correct. So probably this one is correct, right? Still I'm saying in a statistic, nothing is 100%. We just say we have enough evidence to say this one is correct, right? And then there is another term I use in my statistics class just to, for you to understand it. We said we accept it, reject, accept. But still accept is not correct. We cannot accept a hypothesis. You know that now. Because nothing is 100% true. Nothing is 100%, precise. So we cannot say 100%. We cannot say accept. We cannot say correct. We just say we have enough evidence, either rejecting or not rejecting, if in real life we want to explain something. So now for our class, doesn't matter. It's okay. Just as long as you understand the concept, everything is fine. So we reject this one. So we are accepting this one, right? So the mean of exam score probably is less than 72. So what should I continue right down here? We reject the null hypothesis. Then the alternative is true, or we accept the alternative. So let me write down here alternative means H. A null is H null. Okay, so that is one case, maybe this happens. Maybe that one doesn't happen. Maybe the p-value we get is bigger than alpha, and we have to make this conclusion. So either this one or this one. So this one will be opposite of that one, right? If p-value was small and we reject the null hypothesis, p-value is big, what happens? We cannot reject the null, right? Or we accept that. So we cannot reject the null hypothesis H0 So what should I write down? We don't have enough evidence, right? We don't have enough evidence. We don't have enough evidence to reject the null hypothesis. So what we are rejecting then?
The alternative.
We reject the alternative, right? If we cannot reject the null, we have to reject the alternative. So then the alternative, then we reject the alternative hypothesis. Okay. So if we are rejecting the alternative, let's say my null was mu equals 0, mu not equal to 0. So if you are making this conclusion, for example, we cannot reject the null hypothesis, but we are rejecting this one, right? So the temperature was equal to 0, right? So we say we have enough evidence to say this one is true. Do you understand this? Do you have any question so far? So the first step, we state our hypothesis, both null hypothesis and alternative hypothesis. For each null hypothesis, we will have alternative, correct? There were 3 different situations for alternative. One-sided, another one-sided, two-sided, right? So we choose either of them based on our study. We will state our null and alternative hypothesis. Then the next step, we are ready to write down and find our test statistic Z. Z is equal to x bar minus mu divided by sigma over square root of n. Correct? Then the third step, we find the p-value. P-value can be either probability of Z less than test statistic because the alternative was less than. Or p-value can be probability of Z greater than test statistic, and we turn this sign, you know that. We chose greater than because the alternative was greater than. Then the third situation, we have alternative not equal to mu naught, and that's why this is our p-value. So this is the third step. The fourth step, the last step, we make a conclusion. How? By comparing alpha and p-value. If p-value is small, we reject the null hypothesis. If p-value is big, we cannot reject the null hypothesis. We reject the alternative. Correct? And that's it. So in this way, do you have any question? we make a conclusion about any hypothesis based study. So let me see what we have here. So as you know, in this chapter also we have to use table Z, because at this point when we want to find a probability, we have to use table Z to find a probability, right? So, oops, right. You could. Okay, so it says, is blood glucose level for obese patients different from 100? It says, assume that the blood glucose level for obese patient is normally distributed with a known standard deviation of 15. So one of the assumptions was having a population with a mean mu and a standard deviation sigma, right? And the other assumption says sigma is known, right? So we have both of these assumptions so far, correct? Then it says, a researcher thinks that a diet high in raw corn starch will increase, what is that? Starch. Will increase or decrease the blood glucose level, which is 100. And then we have a sample of 30 patients. So one of the other assumptions was having SRS of size n, right? Which is correct. So we have SRS of size n, which is 30 patients. Then we know sigma is 15, right? It says the mean glucose in this sample of 30 is 140. Then there is this 100, I still don't know what is this, but you will understand. It says the blood glucose of patient, for obese patient, different from 100. It says state your hypothesis using mathematical notation, like the way I wrote down. We have H0 and we have HA, right? Null hypothesis, alternative hypothesis, correct? So we are talking about mu, correct? So on this side, we should have mu. Null hypothesis is always is the claim of equality. No difference, no change, no effect. So what we have here in front of mu, equal sign, correct? And then this one. So what is the hypothesized value they are talking about? Do you remember mu naught? Hypothesized value. What is that? So they are comparing, and they have a claim, right? And they have a specific value in their claim. So what is this specific value? This is mu naught, right? So what is mu naught in this study? Huh? What is that? Mu naught is?
Would it be 100 or 140?
100.
100, right? So they are saying 100. They claim that the blood glucose sugar is not different from 100. And then in that sentence also you can find the sign for alternative. So let's say now we know this 100 is the mu naught. What is the sign of alternative now?
Oh, it's
It says not different. Not different from 100, right? Not equal to. Correct? Because they didn't say either less than or greater than anything like that. They said not different from 100. So, this is the alternative. And now we have stated our null and alternative hypothesis in a form of mathematical notation. So our alternative is two-sided, correct? It says calculate the test statistic. This is the easiest part. Z test statistic is equal to x bar minus mu naught divided by sigma over square root of n. Correct? Then I listed all the information I have. X bar is 140, right? Minus mu naught is 100, sigma is 15, square root of 30. Do you remember I told you first calculate this and then divide 40 by this one? Don't go step by step. Don't divide 40 by 15 and then square root of 30 because most of the times students get the wrong answer. What is that? 2.73. Z value should be 3 digits, right? So, do you have any questions so far? What happened?
It's 14.15.
The 2.73 or 4 is the result when you divide 15 by the square root of 30. So that's the denominator. So basically we still need to divide 40 by 2.7.
Oh, give me that answer.
And then the answer is going to be 14.652.
14.6.
14.6?
Yeah.
Well, that's too much. So 40 divided by 15 divided by the SQRT of 13.
Let's just reject.
So let's keep it like that. But there is a number missing, like either 0 something missing. It should be 1.46, something like that. So four. So it should be 104, not 140. It should be 104. There should be a mistake somewhere because the number should not be that huge. 104. Yeah, 140 is a really huge mean for this one.
So 1.46.
1.46.
Yeah.
Okay. So 104. Do you get this?
Yeah.
You just had a mistake. Yeah, I just had a mistake. You did that. Okay, so Z is 1.46. So what was the next step after test statistic?
P-value.
P-value, right? P-value. P-value. Okay, P-value based on Z equal 1.46 and the alternative which is not equal. So the p-value is equal to 2 times the probability of Z greater than absolute value of test statistic. So 2 times probability of Z greater than absolute value of 1.46 equal to 2 times the probability of Z greater than 1.46 because it's a positive number, right? Equal to 2 times 1 minus the probability of Z less than 1.46. And this one comes from table A on the left side of Z equal 1.46. Do you have any question?
Do we do this to every single one? Or it's just the one for one that goes not equal to?
So I wrote down the formula, so I wanted to kind of make it easier for you. So that's why I continued this to this one. So it means whenever you have greater than, you have to switch the sign, right? And you have to subtract from 1, correct?
Yes.
Because now after all this, this kind of question we solve, now if we are dealing with the right side of Z, we have to switch it to the left side, right? By subtracting from 1. So in this situation, greater than, we have this. Then let's continue. 2 times 1 minus, what is the probability of Z less than 1.46? Do you have it? .46 positive Z, correct? 1.4 is here, 6 is this one, 90 to 79, correct? 1 minus 0.92 79. Am I right? No?
0721.
2, 1. Correct? So multiply this This is coming from table A.
Oh, okay.
This 90 to 79. Correct? Then subtract it from 1, you will get this one. Then 2 times of this will be
1442.
0.1442. Correct? 0.14.
Wait, so what happened to the whole P and the A?
This one. So 1.46 comes from this z-test, right?
I know, but I'm saying what happened to the whole thing because you should put 1 minus.
1 minus, instead of probability of z less than 1.46, this one from table is 0.9279 because this is the left side of 1.46. So the probability of z less than 1.46 is 0.9279. So this is the p-value, right? So what was the next step?
Compare p-value with the alpha.
What is the alpha? I told you they will give you alpha in the question, right? So let's see what is the alpha. So I didn't give you the alpha. 0.05. Oh, actually, these are the new question I wrote down. That's why I didn't edit them. Oh, let me change this. This was 104, right?
Yes.
Okay. So alpha is 0.05. P-value is 0.1442. So what should I write down? P-value greater than alpha or less than alpha? P-value is greater than alpha because this one is 0.1442. This one is 0.05. Correct?
It's going to give us the alpha.
Hmm? Yeah, I will give you alpha in the question. So what is the conclusion here? When p-value is big, we cannot reject the null hypothesis, correct? Cannot reject the null. So reject the alternative. If we cannot reject the null, we are rejecting the alternative. So what is our conclusion? This is our alternative. We are rejecting this one. As we said, we have, actually we don't have enough evidence that, what was that? Blood glucose level? Blood glucose level is different from 100. Do you understand this? Still, we are going to solve more questions. Okay? So, please work on this. This is the first time we are using this notation. I talked about this kind of way of writing down, mathematical way of writing down probability, but we didn't use it like this. So maybe that's why kind of little bit difficult for you. Do you have any questions? Nope. You're on the way of camera. Front of camera. Okay, so next time, Monday, we are going to continue this, solve more questions, and we have just 2 lectures, right? Next week. And then final comes, and then we have a review before final, probably one whole section. And the next time also, as soon as we are done with all these questions for hypothesis test, I'm going to again solve some confidence interval questions. Okay? Take care, have a good weekend. We'll see you on Monday.